Today we're back again with another graph sketch, an aspect in maths I really like, and you should expect to see loads of different sketches with different shapes and natures to be posted very soon. So our task is to sketch x sine of x. Well, the first thing I'll do is find out if our function is an even or odd function. An even function is defined as when f of minus x equals f of x. And an odd function is defined as when f of minus x equals minus f of x. So f of minus x equals minus x sine minus x. Well, we know minus x just is minus x, and sine minus x evaluates to minus sine x. The reason being is sine x is an odd function as it rotates 180 degrees about the origin, and we know that an odd function f of minus x equals minus f of x. We can rewrite this as minus x times minus sine x. So f of minus x equals x sine x, which is just our original function. Right. This means that our sketch is symmetrical about the y-axis. So now let's consider our domain. Well, the domain of sine of x is just fx, where fx is between minus 1 and 1. So if we sketch our graph of sine x, not the best of sketches, but it will work. So let's consider our graph. Let's consider x when f of x equals 1. So at these points here, so at 90 and at 360. No, sorry, 90 plus 360, which is 540. We have f of x equal to 1. So in terms of our bigger function, we have when f of x equals 1, we've got an input of 90 times sine 90, which equals 90. So when x equals 90, f of x equals 90. So we can say when x equals 1, f of x, when x equals 1, f of x also equals 1. Therefore f of x equals x when obviously f of x equals 1. Similarly, we can make an argument for when f of x equals minus 1. So at points such as 270. Right, so if you've got fx equals 270 times sine 270, which equals minus 1. So f of x equals, we got fx equals negative x, where f of x equals negative x at when f of x equals -1. So what does that look like for a bigger sketch? So if we've drawn y equals x and y equals -x, we know our function is bounded by x, y equals x, or f of x equals x, f of x equals -x. So let's write in our inputs: 980, 270, 360. Essentially, we've got a sine graph that has been, in a sense, extended. So we start at 0, 0, because when x equals 0, f of x equals 0, and we've got 0.90, 90, come back down. We've got 270 and -270, and since our sketch is symmetrical about the y-axis, we just copy this on. And this is how we sketch f of x equals x sine x.